Hi everyone, I hope you are okay. And so, as I told you on the WhatsApp message, today we are going to be looking at a potential divider. So, I want you to study this circuit very well. As you can see, it is a circuit that consists of a power supply source whose EMF is 12 volts, which is connected in series with two resistors R1 and R2. As you can see, R1 and R2 are in series, and then the circuit is closed. Now, across R1, there is a voltmeter V1, which is connected to measure the voltage across R1, and across R2, there is a voltmeter V2 that is connected to measure the potential difference across the terminals of the resistor R2. As you know, when two resistors are connected in parallel in series, it is the same current which flows through them. Now, what will happen is, if you look at this circuit, right from here, we are assuming that the connecting wires have no resistance at all, and the cell has no internal resistance. So what does it mean? If the cell produces a voltage of 12 volts, it means each coulomb of electric charge is given 12 joules. And so when the electric energy comes here, because this is a resistor, there's a lot of energy which is required to push electrons or electric charges across resistor R1. So what does it mean? It means some voltage will have to be, some energy will have to be used across R1. So there will be a voltage drop across R1. And there's also going to be a voltage drop across R2. But the voltage across R1 and R2 must add up to 12 volts. And that's why we are saying, if for instance, R1 is a variable resistor means the resistance can be changed. It's not fixed. If you look at R2 right now, the way it is a fixed resistor. But if it is a variable resistor, it means its resistance can be changed. So if resistance of R1 at this moment is low, the voltage across R1 could be like 2 volts. And if the voltage across R1 is 2 volts, then the voltage across R2 will be equal to 10 volts. So that 2 volts plus 10 volts is equal to 12 volts. Again, if we increase the resistance of R1, because it is a variable resistor, to a higher value, higher than before, the voltage across R1 will then increase to 4 volts. And if the voltage across R1 is 4 volts, then the voltage across R2 will be 8 volts. If the voltage across R1 is 9 volts, then the voltage across R2 is 3 volts. As you can see, 2 plus 10 gives you 12 volts. 4 plus 8 gives you 12 volts. Even 9 plus 3 gives you 12 volts. So this arrangement here is called a potential divider. It divides the potential difference, the total potential difference applied